right, so congratulations, you've written some code, but you're going to need a test for that. So you're going to need a test for that as the title of this talk. My name is Lara Newsom. I'm a software engineering technical lead at Cisco. You can reach out to me on these social media platforms. My messages are open on LinkedIn. If you try to connect with me on Twitter, you will find me there, but I've been locked out of my account for over a year, and I quit trying to get in, so I don't live there anymore. So the reason I wrote this talk is because as a technical lead, and honestly as a software engineer myself, the biggest question that I get is, how do we test this? Does it need to be unit tests? Do I need to write end-to-end tests? And this is the question I field with my team constantly. Specifically, where do we test this? How do we test this? How do we know how to test this? All of these questions. So the key takeaways I hope to give you for this talk are what kind of tests are there available for Vue developers? How do we break down feature testing strategy? And how do we build test suites that work for you and your team? So you've probably heard of the testing pyramid. The idea is that we want to write the most unit tests because they're faster to run, easier to write, less expensive, slightly less integration or end-to-end tests. And then we don't want to do very much manual testing. And this is really cute, right? Like this very simple pyramid. Well, this is what my actual CICD test suite looks like. It's often multifaceted. There's lots of stuff going on, often in different test runners, right? So it's never quite as straightforward as that cute little pyramid they show us. It's also really important to remember that testing is an evolving practice, and your test suites will evolve over time. So on my current team, when I started, we had about 40% test coverage, and most of those tests didn't have expects, or they would do things like component, invoke method. Did the method get invoked? It did, you just did that. So they were very low quality tests. Now we have over 80% coverage and significantly better quality. So we have to expect that there can be growth in testing. So one of the questions I ask myself when I'm trying to decide how I'm going to test code is, first of all, what does the code do? Because that's going to help me understand how I need to test that. This is the biggest question I ask. The second question I'm going to ask myself is, who uses this code? I'm going to test code for an internal application used by a handful of users, probably a lot less than I would test code that was on a public-facing, very important website. It's also important to understand how your code is written. How you write your code will dictate how you test your code, what languages you're using, what frameworks you're using, how your code is released. So if you're using a CICD pipeline, can you run your tests in the release pipeline? Or are you still releasing manually and you need to figure out how and when to run those test suites? And then what is the purpose of the test really goes along with what does the code do? So what are we trying to achieve by writing these kinds of tests? So testing tools really depend on your code base, the preferences of your team. So you may have a team full of Playwright, people who have experience with Playwright. It wouldn't make sense to switch them to Cypress unless you've got some really good reason for that. Also financial constraints. Some testing tools are not free, and they can cost extra money to run in pipelines. So since this is a shorter session, it's a 30-minute session, we're going to really focus in on pre-deployment testing options. So these are the testing strategies that I use before I release my code. So static code analysis, unit tests, component tests, integration tests, end-to-end tests, and visual regression tests. So I'll get into a little bit of what those are. But as Vue developers, Create Vue will scaffold out static code analysis through linting, unit tests, and your integration and end-to-end test suites for you. So that's very handy. So static code analysis is going to analyze your code without executing it. So it's including steps like linting or type checking. Your IDE plugins, like the Vue language server, are going to run as the code is being typed. And this can help prevent build errors and enforce coding standards. So if your team has agreed to a certain set of lint rules, you can enforce that without even executing the code. Unit tests are the smallest functional unit of code, testing those in isolation. So it's actually executing the code. These are meant to be quick to write and quick to execute. And so these are really going to be great for testing things like JavaScript services, composables, functions, those kinds of things. And these are really good for when you want to get all your coverage on your edge cases, right? So if you're expecting a bunch of conditionals, you can hit each of those conditionals in a unit test fairly quickly. There's also the idea of the component unit test. So this is where you're actually mounting or rendering the component. And this can be used to test your behavior of your UI component by rendering the actual template of it. And it requires a framework-specific test library to go ahead and render that template. And then we have component tests. So this is sort of like the next layer of the much larger pyramid than they let us believe. These are going to test parent and child components together. This is sometimes referred to as module testing. And this is really good for feature development, but they also take a little longer to set up and a little longer to run and execute. So that's where the trade-off is with those. Now, there's a fine line between integration and end-to-end tests. So integration tests I consider to test multiple sections of the code together. But this is not testing the full system end-to-end. So you won't necessarily have your APIs up and running, and you won't be hitting those in the background. But these are really great for testing your user flows, like to make sure if I click here, does it actually route to the page that I expected to route to? And again, these can take a little longer to write and to run. So a little more expensive, so you want to be a little more judicious about how you write those. Now, end-to-end tests will test the whole entire system. Now, because it's testing the whole system, it requires the entire system be up and running. And so this can often require a lot of significant setup to get all the resources to run. So for example, on my application, it's actually not possible for me to do local end-to-end tests because I would have to spin up so many Docker containers to run servers so that we could actually hit the backend services. And these can be prone to being flaky, because since you're actually hitting services, you can end up with data issues and stuff like that. But these are also a really important piece of full CICD. So this will give you the confidence that the entire system is working together. And then the final piece is visual regression testing. Now, this often gets overlooked, but this is testing the way that the UI is supposed to look. It's using snapshots. And this is good for code that's already been developed. So where I like to use visual regression testing is it helps to prevent accidental changes to styles or HTML structure. So it's pretty easy to fat finger in a template and actually add in an extra closing bracket or accidentally change a style that will affect pages that you maybe didn't realize that you have affected. So that's where these visual regression tests can help you catch that. So these types of tests can be automated to run locally or in a CI/CD pipeline. And then you need to define sort of the boundaries between the types of tests. So when I'm in North America, I use this slide about what we call pop or soda or Coke, but I didn't think that would work here. So instead, we're going with beer. So what do different countries call beer, right? So we got to set up our boundaries. All right. So the first question I said is, what am I trying to test? So we're going to, for the rest of this talk, we're going to run through our featured products section of the Just Like People Pet Boutique website. So this is a new feature, and I need to develop a testing strategy for this feature. So the featured products component has two dependencies, the product service and the card view component. So if we look at the code for that, we can see that it's importing the card view, and then it's using the product service to get the home products. The product service is using use products, which relies on a fetch service behind, under the hood. And so that's where we're actually getting our products from. And then the card view component has a dependency, sorry, I went a little fast, on two different components. So our price view component here is being imported, and so is our add to cart button component. Digging down further, the price view component is actually, it's relying on the sale message function to determine what to print here. So if there's a sale price, it'll give us the message to let us know how much money we have saved. So we see that dependency here. And then the sales message is just a JavaScript function. So it takes in sale price and determines what string to publish. So we've got our add to cart button component. That uses the cart item store under the hood here So we're going to use that cart item store to add or decrement items from the cart. OK. And then the cart item store has a dependency on fetch as well. So this will actually make requests to and from the server. So when we map this all out, we can see this sort of graph, this chart of dependencies, right? How is this feature built out? And this is how this specific feature is built out. So now I have to decide my testing strategy. One thing I like to do before I do that is I define what user flows I expect to find. So one of the things my users can do is they can click on products to redirect the. So if you click on a product, it should route to the detail of that product. If I click on a plus button, it should add items to the shopping cart. If I click on the minus button, it should take them away from the shopping cart. If I click on the center button, it should add items to the shopping cart. So those are the things I expect my user to be able to do. I'm going to run static code analysis while I'm doing development on this. So running linting, formatting, the view language server. So IDE plugins are going to run while the code is being written if you set them to do that. You can also leverage Git hooks to run like linting or formatting. So on my team, we run formatting on commit and linting on push. And the reason for that is linting takes a little bit longer. The longer running the process that you attach to a Git hook, the more likely your team is to --no verify it. So know this for a fact. So then we're going to get to the unit testing layer. So when we're looking at unit testing this feature, we're going to want to unit test each individual piece of this, right? So if we look, we've got 6 different things that are really, they can be just basic unit tests. So these are going to be services and functions that are just JavaScript. So all we need to do is write some basic unit tests for those. As a Vue developer, we have options. vtest is the create Vue default, so that's what I've used for my examples. But here we have our sales message function. So this has no dependencies, and the state is simply passed into this. So the unit tests for these are going to be pretty straightforward. I've got 2 conditions I want to cover. One, if the sales price is defined, and one, if the sales price is not defined. So that's covered. That's 100% covered at that point. Under the hood, the product service is using useProducts, which uses fetch. Now, this is actually, fetch will actually hit an endpoint, right? So I want to mock the service. I don't actually want my unit tests making requests to my APIs every time I run them. So what are mocks, and when do I use them? Well, mocks provide implementations that meet interface requirements. This allows me as an engineer to determine what values are being returned by the mock dependency, so I can really fine-tune and control the setup for my tests, so I can determine, so I can catch all the edge cases. So why should you mock? Well, because sometimes implementation details change, right? I think it's probably happened to all of us where you change a very minor thing in some component somewhere, and it turns out that it's, or a service, and then you end up having to fix a bunch of unit tests because that service wasn't mocked. Actual data can change, especially dev data. So if you're trying to unit test against actual real data, it's very frustrating, and it will probably break your brain. It's also easy to set up tests for edge cases if you're controlling what data is coming in. So in this case, we're going to mock, to test the product service, we're going to override the fetch service so it can't make requests at all. And then we'll provide a mock for the used products. So I prefer to mock anytime I'm using a third-party dependency, because they can't guarantee me that the implementation isn't going to change on that. I always mock if it connects to external resources. I don't want to burn up my resources because of my unit test suite. And anytime something is performing a complicated calculation, I don't want to try to figure out what to expect the service to spit out at me. And then also anytime implementations might change. So for our product service, we really have 3 cases we want to handle. So I figured those out, and I basically just looked at my code to determine what could happen with the method that I'm trying to test. And so for the unit test, first I want to create a mock that's going to stop fetch altogether. It's not going to allow fetch to make requests. So I use vmock for that. But a better implementation of this would be to provide a global mock so that none of your tests can actually hit the endpoints. Because if you do it on every test file, it's guaranteed that somebody's going to forget it somewhere. And then I'm going to use spies to tell useProduct what to return to me. So in this case, I've set up a ref that I'm returning through the spy, and then in each of the unit tests, I'm setting the value of that ref so that I know, so that I can get that value out of it. So there's different strategies for mocking values in unit tests. There's libraries that exist out there that you can use. The best strategy for you is the one that works for your code and works for your team. But it is a standard that it's good to set because then people can follow along on the tests. So we've tested our services. We could follow the same patterns to test through all these services. I'm not going to walk you through all of that. Let's test a component next. So we have our card component. This is one of the children of the feature products component. So I like to ask myself, what does the card do? Well, it displays an image for the product, right? And there's a link on that. You can click on the title. There's a link there. It's showing the price. Let's see. We've got that displays the price and includes a message if the product is on sale. And it'll allow you to increment the cart button to indicate if you've added or removed items from the cart. So if we're going to go to test the cart component, let's first look at unit tests. But if we actually look at the component itself and look to see what it is doing, it's actually only rendering an image with a link. It's providing the title with a link. It's rendering the price view component, and it's rendering the add to cart button component. So the unit test for this component really should not be testing beyond the boundaries of this component. Because at any point, implementation could change on the price component. Implementation could change on the add to cart button component. So if you're writing your unit tests on the cart component to try to reach into those children and test the functionality of those, you're setting yourself up for fixing a lot of tests later if anything changes. So we're actually going to test these two items when we get to those components, unit testing. So for cart component unit testing, so this is not just a simple function. This is actually a component, so we want to go ahead and render that. We're going to go ahead and render it, and then we're going to write 4 test cases to determine if the image is rendered with the router link, if the title is rendered with the router link, and so on and so forth. So in Vue, we have 2 different unit testing libraries we can use. There's Vue Test Utils, which is supported by the library, and then there's Vue Testing Library, which is like the cousin of React Testing Library or Angular Testing Library. So in our cart component unit tests, if we look at our case where we're checking to see if the image is rendered with a link, I'm going to go ahead and mount the component, and I've got the wrapper here. So I like to use the ciphers method where I write a setup function as opposed to using before each. But this is, again, team preference. So this is me setting up my tests. I'm returning the wrapper, and then I'm going to find all the links, and I'm going to determine if the image element is there. And I'm going to check to make sure that it rendered the correct source. There's the arrows that show you the expects. So, but then we get to the price component. So one way I could test the price component is I know that I passed the price into the price component. So I could assume that if I check for the price to be rendered somewhere in the wrapper, that I should find it. But what if the card component or the price component changes? So another way I can test that is to use shallow mounting. So I can avoid testing implementation details of my child components if I shallow mount my components. So in this case, I'm setting the shallow mount in my mount function. I'm setting shallow to true. And then when I test, I'm just going to test to see if the stub is there for the price view. And then this way, if anything changes on my price component, then this test will continue to pass because all it cares about is whether or not it rendered the component. So there's a difference between deep rendering and shallow rendering. Deep rendering is going to render the component and all of the children. It requires all of the child dependencies. It tests component interaction, so there's a plus to that. But it also couples the test to child elements. Shallow is obviously the opposite, where it renders only the component under test, but this requires stubs or shallow mounting. And the benefit of this is that if the child implementation changes, the parent tests do not need to be updated. I will give you the slide deck at the end of this. There's several articles here kind of debating this. It's a debate, right? You can do a little bit of both even. Every team I've been on has waffled back and forth to be what's the better way to do this. Kind of where my team has landed is if you have a really complex child component, stub that thing because you're going to drive yourself crazy trying to provide it all the dependencies. So there are unit test gotchas, right? So it's going to be very, very tempting to try to test into this child component and this child component, right? It's the first thing that my team always does. It's the biggest mistake they make. The other mistake that I see a lot in unit testing is trying to test the actual Vue framework, right? Vue is tested. Do you really need to test that the framework works, or are you testing that your code works? So trying to make sure that you understand the boundaries of what you're trying to test can help prevent you trying to write very frustrating tests. So setting clear test expectations can prevent doing too much work in tests, because the hardest code to test is the code not actually owned by the unit under test. So if I have a hard-to-test component or I have a teammate that's struggling with testing, I ask them, are you trying to test beyond the boundaries of the code under test? Also, can your code be split into smaller, easier-to-test units of code? Right? We have composables in Vue. Like, there's a reason that they exist. You can split up your code into smaller, functional pieces of code that are easier to unit test. You can split very large components into smaller components, again, to make them easier to unit test. And then, are you testing implementation details instead of results? All right. So for the rest of those components, we would follow a similar pattern of mocking, stubbing, potentially shallow mountings, potentially deep rendering. And then we get to the card view component test. So in a component test, what I actually do want to deeply render this, because I want to make sure that when all of the elements are rendered to the view, that they are correct. I want to make sure that the price component is displaying the correct method, and that when I click these buttons, I'm seeing the correct behavior. We have technically two component integration testing libraries. I say technically because Playwright started doing component testing, and then it's been in experimental for 2 years, right? So really, Cypress is your best bet with that. And I found a video by Mark talking about testing Vue components with Cypress. All right, so then we get to card component visual regression testing. So this is the next test I can do on this specific component. And so what I want to check is that the rendered view matches the snapshot from the last time this product was rendered. So this is going to help us catch changes to the styling, essentially, or the actual content of the page. So a really small mistake to a design token can make a huge difference to the page design. Right? So I might not notice that I changed this color in code review, but my clients are going to notice this for sure. There are different options that work with Vue. A lot of these are paid services, so it's a matter of figuring out what works best for your team. And then we're going to pull it back a level, right? Because we've fully tested that card component, but we need to see how this card component behaves in the entire system. So we're going to do some integration testing. So in this case, I want to test that when the user clicks on the title or the image, it's actually going to route me to that product detail. I want to test that when I click on one of these buttons, that this number up here in the cart is changing. And then if I navigate to the cart component, I want to make sure that items are actually getting added to the cart as expected. So that's my integration test. So integration tests are like component tests, but they're testing how the feature behaves with the rest of the components, like with its parent components as well. So this is a test I wrote. Basically, this is just going to test the interaction. That's all you need from that. and then we have end-to-end tests. So in an end-to-end test, this is where we're actually running against the maybe the APIs in dev. And this is where we actually want to see what happens when we add or remove items from the cart. Is that actually getting proliferated to the database? And when I make a purchase, is it actually processing my purchase? right? So in these situations, a lot of times you need to do test setup and test like data setup and data teardown as well to make sure that every time you can expect the same values. So they take a little more work, and they can be a little risky because sometimes you're depending on the whole system to be up and running. So a true end-to-end test would test that the user interactions are successfully updated using the actual API endpoints. So for integration or end-to-end testing, we have several options that we can use in Vue. I prefer to use Playwright. In Playwright, to do integration tests, you can actually mock out the return value from the endpoint, so you can pretend you got values back. And then for the true end-to-end test, you can actually let those requests go through. So we've kind of mapped out our strategy for testing the product, the featured product feature. There we go. But what about code coverage, right? Because that's something that everybody has to hear about. And we've all had this boss, right? Well, I've heard that code coverage is better. So 100% code coverage, that must be the best. So now it's required. And then all of your devs look like this, right? And you start seeing commits in your code base that look like this. And the PR message is something like, getting that test coverage, right? And they're not useful tests. So 100% code coverage rarely yields high-quality tests. Now, my hot take on this is that all of the code you write should be 100% testable. That doesn't mean that you have to get 100% code coverage, but you should be able to, right? But we do still need some code coverage requirements, because we all know what happens if we don't have any. Then we don't have any, because nobody really loves writing tests, unless you're kind of weird like me. So you can, when we decide how to set code coverage metrics, now just like your testing strategy, this can evolve over time. So I like to look at what is the current code coverage in my library, and what is the current state of the tests? Like, are they in good shape? Are they actually testing useful things? And then what would be a reasonable improvement, right? And so we can set targets over time to say, you know what, this sprint, we want to increase our code coverage by 2%. Or whatever makes sense. Because you can improve coverage over time, and you can improve coverage by directory or file. So you can set the code coverage metrics globally, by directory, or by file. And so the nice thing about this is if you write a new feature, like our featured products feature, I can say, I want to make sure that this has 100% code coverage, because I know I can get it, or I have it already. I don't want it to backslide, right? But I know I can acknowledge that I've still got some legacy code, and I need to be a little bit forgiving on the metrics there. So when you're creating a testing strategy, the first and the most important thing to do is determine the needs of the code base. You need to agree on a testing strategy with your team. And you need to also remember that not only are you developing a test suite, but you need to develop a test suite that you can maintain over time. That's all I have for you today. Thank you so much for joining me. And then this is a link to the slide deck. So.